Hello, this is Mike Wall from LM3 again. In this tutorial I'm going to go over the fastest way to get a detector up and running. So I start off with the label and train program. Let this start. And I'm going to navigate to just an empty folder that I created. So today's date. Select the folder. There's no images in it, so it won't show anything. But you can see that we're in beginner mode. So this is beginner mode in the settings. And I'm on capture. So there's four basic parts to this. Capture images, label images, package the images for training, and evaluate. So over here on the right I have the options for capturing. In this case I'm going to use camera 1. So I already set up the camera. And this is just about setting up a detector. So I press go and wait for the capture dialog to pop up. You can see in this image I have a number of blocks that I'm going to be working with some defects, and then some of the similar blocks without. And what we're going to do is just get some pictures of them slightly rotated around. So I'm going to do 10 pictures, just in different rotations. And this is just to get, so I'll rotate again. I'm going to snap a couple. 1, 2, rotate a little bit, just on their axis so that it's easy to label. Rotate a little bit more. And then these blocks are a little bit different depending on which side they're facing. So I'm going to flip a couple of them over. Get a few more pictures. Now you could use the PAQi software to get your pictures as well, but I find this is the easiest way to get started. I'll get a couple more and then we'll go ahead to the next step. Okay, so I'm going to stop there. And then I'm going to reload this folder. So open directory, and that'll load up all the images that I just took. So now if I go to the label option, you'll see over here on the right, I have my list of 15 images that I just snapped. And I'm going to go ahead and just label them. So make sure I'm on the first image, and then I'm going to do create rectangle box. So we call this circle. Plus square plus we call this one bad circle because it's got some defects in it. Add triangle. Okay, so let's just take a look. Here's all the labels that we've put down. Should be 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Then we got a circle, got a plus, square, another plus, bad circle, a bad triangle, and a bad square. So let's go ahead and save. And then we're going to use this copy labels function to copy across the others. So it's going to give me a little warning saying, are you sure you want to replace all of them? And the answer is yes. And I'm going to use the edit rectangle box to just make some adjustments. So as I was moving them, they shifted a little bit. You don't have to be perfectly on top of the objects, but get them centered. Notice I'm not using any kind of lighting control, so this is just ambient light. And I'm in a well lit room with outside lighting, so the lighting is going to vary, and that's okay. Key to all this is to provide as much variance that will be seen in production as possible. Let's move that. Notice that this 1 plus was flipped over, and this is one of the original images where we can see the defect here on the right side. So we want to make sure we label this one as bad plus. It was labeled as a plus because we copied from the one that had the good side up. So same with this one. All I'm doing is right clicking to do that. Actually, I don't want a space in there. It's fine to have a space, but I'd like to get some consistency, so I'm going to go back and label the last one properly. Okay, so everything is labeled now on these 15 images that I took. So I'm going to go to the package option. And in this case, I'm going to create a new detector and a new evaluation folder, because evaluation is part of this process. So say add new. Task list is just going to show me what's going on. For example, we were copying labels before, and we were doing snap and detect. So now I'm going to click go, and I'm going to call this colored blocks. There can be a space in it, that's fine. I just choose not to put spaces. And hit enter. You'll see a little augmented started, which indicates that the packaging process is in process. This takes a few minutes, so we'll wait until it completes. Okay, so the packaging process has completed. So that it gives us an augmentation complete message, and then it pops up the location of the zip file that it created for packaging the data ready for QC Hero for training the detector. So at that point I can go ahead and open up QC Hero. This is all online. So I'm in QC Hero. I'm going to create a new detector. I'm going to name it the same thing that I called my evaluation folder, colored blocks. I'm going to choose Optic Detector for the type of detector, and then create it. I'm going to go to the Training Data tab and upload new data. I'm going to go to the 9.8 folder that I had created, which contains the packaging file or packaged file for QC Hero to use for uploading the training data. And I'll wait for this to upload. This is purely dependent upon your internet speed, because all we're doing right now is just uploading data into the cloud. So all of the images have uploaded. You can see that we have 406 total images. They're all labeled. And then there's a list of objects shown. We have a decent spread. Of course, the bad plus is got half as many as a good one because of the flip. So this all looks good. At this point, we can do train new version. Since we're starting from scratch, we're going to start from scratch. Whereas if there were already trained model, we could use it to train more, which I'll get into later. And I got a choice between GPU or TPU accelerator. TPU is faster and same cost almost as GPU, so I'm going to use TPU and begin training. So this process will take between an hour and 2 hours, depending on how complex your application is. So at this point we can go off and do something else. Wait for it to complete. Okay, so after 2 hours and 17 minutes the detector has succeeded at 100% accuracy. The graphs show that the loss gradually went down, which loss is a representation of how well the detector predicts the position of the objects relative to how they're labeled. And then accuracy in relationship to validation is how well it predicted the class, the object, relative to the labeled object. So this one went to 100% quite quickly. And when the loss leveled out, it stopped training. And we have a near perfect detector for the blocks. So in order to install it, we go to versions. We've only trained this one once, so we're just going to download this version of it. And then I'm going to go back to the labeling software. So this is where we left off on packaging of these images. And we're going to go to evaluate in this case. So in order to do evaluation, we're going to pick the internal folder that we're in. So we're in the evaluation folder for colored blocks. And we're going to do add new for detector name. Hit go, and then we'll be prompted to select the QC Hero zip file, which is going to be in downloads because we downloaded it. It's right here. And it's named detectors, color block, version, number. I'm going to double click on that. Wait a few seconds and it'll load the detector. So you get a prompt that says it's going to be put into temporary mode, which allows you to install and evaluate detectors that have just been retrained so that you can keep running the detector that's running in production. So hit continue, and then when the detector is loaded you get a message saying it's been added as a temp. Say OK to that, and then the evaluation routine will go through all the images in the evaluation folder. These are images that were not trained on. So these are basically raw images. And a lot of these are augmented as well because you can see the background lighting changing. And these green boxes mean that the detector is able to detect the correct objects in these locations. And over on this bottom right, this table shows what objects are being detected, what their pass-fail rate is, if there's any false positives, the average score, and the minimum score for use in setting the score thresholds, which we'll get into later. So we can let this run to the end and review the results. So evaluation is complete on all 101 images. And there's 0 failures, and if you're looking at the minimum scores, they're all near 100%. So this is good. This is a capable detector. So we're going to go ahead and install it. So install puts it in permanent production, and then from there we'll do some additional validation and calibration. So once the detector finishes loading, tell you it's been moved in production. One of the other things that you can do if you have some failures is segregate them into their own folder so that it's easy to review them and see if they're labeled incorrectly, or label them and push them back up to QC Hero to train the detector more on the failures. So I'm going to go ahead and stop this. And we're going to go ahead and get some pictures of these blocks in different areas, or different positions. And then we'll do some evaluation on those different positions. So back to where we started, we go back to capture at this point. And I've moved the blocks around some from the original. But before I do that, I want to create a new directory and just kind of segregate these images off so it's easy to do an evaluation on them alone. I could just put them in the same directory, that would be fine, but this will make it faster. So I'm just going to create a new directory in the evaluation folder, which is that stored images evaluation, called colored blocks, second eval. So I just create that in Windows, and then over here I'll go to that folder, and then I'm going to use the capture function to get some images, as we did from the start. So I'm going to go ahead and select camera 1, hit go. So probably don't notice, but these blocks are in different positions, and I'll move them as I capture some images. So changing the bad circle into the good square, now the bad circle and the bad square, bad circle and good triangle, good square and good plus. Flip over the plus where we have a defect. And I'll change the good plus with the bad triangle. Flip it over as well. Just get a couple more variations here. Okay, I've snapped 10 images in different positions. Go ahead and stop the capture. And then I'm going to go ahead and load this folder. So these are the images that we took. Notice the lighting is a lot different than the original pictures, which should be okay. We got two options at this point. We're going to do another evaluation. So one option would be to run evaluation just on the raw images, which is going to result in failures, because false positives, because I haven't labeled any of these. The other option would be to label these 10 images and then run evaluation, but I'm going to take the lazy approach and just run evaluation against the raw images. So I'm going to go ahead and go to evaluate, select the colored blocks, detector, and then I'm going to use the internal folder that I'm in. And I'll go ahead and run the evaluation. And you'll notice as it's evaluating, it is putting down red boxes. These are all false positives because the images weren't labeled. So it's finding the objects, and it's looking at the label and saying, I found objects that you didn't label. This is to be expected. The nice thing is, running in this particular mode, that when I stop this and I reload the images, they'll now be labeled. So it does the labeling for me, and it's akin to doing auto generation of labeling. So now that I've run the evaluation against the raw images, they're all labeled, and I went back and corrected anyone that was double labeled due to finding multiple classes on the same object. And now I'm going to run another evaluation against this set. So back to evaluation, color blocks, internal folder, go. And so now it's doing evaluation against the corrected labels, and we can get a feel for how the detector does under different conditions, blocks in different locations. And then next we'll start to run it in more of an automated way through the PAQi software with the calibration in place. Okay, so it looks like we have one that failed. So I'm going to segregate this off. Okay, 2 images that failed. So now if I stop this, I can go into the failures folder and we can see what got labeled what. So let's go to labels. We can see we have 1, 2, 3, 4, 5, 6, 7. So there's 8 labels, which is what we expect. No double labeled items. Let's just go through these. That's bad circle, bad square, bad triangle. It's a circle only. It's a plus. It's a plus. It's a square. And that's a triangle. So this did work correctly, and we had one incorrectly labeled, at least one image as far as the objects go. So it wasn't a problem with the detector, it's a problem with labeling. So by running evaluation, as mentioned before, the labels get automatically generated, so I didn't really need to do anything. So let's look at this one. Bad circle. So this is a flaw in the system to be able to detect this bad circle, or bad triangle. Actually, a good triangle is being detected as a bad triangle. So that would be more of a false failure type condition. Circle, good, good, good. Bad square, which is what we expect, and a square. So there's one failure in the mix where this triangle got detected as a bad one. And we could go and train more on images similar to these. Or we could let it run in production and then train when we have more images, which is what we're going to do. So now we're going to set up a real inspection. Notice I started the operational program. This is version 9.9.3. First thing it does is that it loads all of the detectors that are inactive and makes sure that they're ready for use. So once it finishes this process, we'll be able to set up a new program. And we do so by going into options. I don't have any passwords set in here, so I just log in. And I go into inspection. Inspection setup, and several parts of this. Sequencing wizard allows you to create a program. Manage detectors allows you to see which detectors are active. So right now we have a blocks active and a colored blocks active, and it shows us the version, the time they were installed. Back. The calibration section allows me to go in and look at which calibrations are available and which objects are expected for calibration, along with the scores. And then we have programs, which are used to set up picture taking, whether or not inspection is done, which detector to use, and which calibration to use as well. So we're going to set this up, so I'll get into this. I'll show what's the details of the setup as I complete them. So I'm going to start in the sequence wizard, and I'm going to set up a program for each one of the blocks. So we'll do square, we're going to run one step on this. We're going to enable picture taking on camera 1. We only have one camera in this case. If you had multiple cameras, this wizard will lead you through setting up each one of the cameras, including if you have multiple steps. It'll lead you through setting up the cameras for each step. So one camera, taking a picture, and I'm going to say yes detect. Notice you can also say yes measure, in which case you can use BBAI to do physical measurements. But in this tutorial we're just going to do detection. So I say yes detect, we're going to use the color blocks detector, and we're going to set up a new calibration. So in this calibration, when we're looking for square, it's called the calibration square. We're going to detect good square only. We're not going to enable order. We don't care in this case. And we're going to be only looking for the square. So we can either mask off all the other objects or we can remove them. So I'm just going to do a masking of all of them. All the other, anything but a square. But it's fine to use the remove objects option to get rid of all the other ones. Using masking, it's not even going to look for those at all. Notice that we have our square threshold set to 75. If I double click on the square, I can increase that or decrease that. We'll just go with 75 to start. And we're going to display as a list for now. And I'll show you how to display boxes and scores after we set up a couple of these detections. Okay, so we got picture taking with detection, step 1, camera 1, no camera profile, and detector color blocks and calibration square. Let's do circle. I'm going to go through this rather quickly. One step, enable, detect, color blocks detector, add new calibration. This time I'm going to mask everything except for the circle. Call this circle. Save. Next. Next. Display the image as always. Upper override disabled. Disable production count mode. And no macro. Okay, we'll go on to the next. We'll do triangle. One step again. Enable. Detect. Color blocks. Add new. Mask everything except for the triangle in this case. Save, all good. I'm not going to reset these settings, so I'll go back to home, sequencing wizard. We have one more, that's the plus. One step, enable, detect, yes, color blocks, add new calibration, select 1 plus only, that's everything but the plus, save, next, everything looks good, next, and now I'm going to close and we'll run these. Let the configuration reload, and I go into options. I choose a username, anyone. There's no password set into it. So that will allow us to choose from a list of programs set up in the machine already. So I have a circle in front of the camera right now. I'm going to choose circle. I'll hit the grab button to take a picture and do the inspection. So it looks like it's scoring this one a little bit low. scoring it at 72.12% when the threshold is set to 75. So let's check it in a couple positions. So we'll move it around a little bit and see what it looks like. It's a little more centered. Likes that one. Move it a little bit more. That's still scoring pretty low, 77%. That one's low, down in a 53 at the top. So this is likely a result of where the circle block was positioned when we were doing training. So in order to immediately alleviate that problem, we can just go ahead and adjust the score. So if I log in again and go to the inspection setup, I'm going to go to manage calibrations, and I'm going to find the circle this time. So circle. And then I can just double click on circle and it'll bring me up the ability to adjust the score. So I'm going to set the score to 50%. And we'll do some testing, make sure that's okay. Close, close. Let it reload. Now when I hit grab in the same location, the score changed a little bit, but it passed. Move it in a different location. Okay, so I'm going to now add a square in the mix. Now you'll notice that since even though the square is there, it's failing the test because, or it's passing the test because we masked off any of the other blocks. So if we were to add a circle, it will also pass the test because this is a bad circle. And we've already masked that off. So let's go unmask the square. So back to the circle calibration. And actually, let's unmask everything. We'll just unmask all of these. And we'll remove them instead. So let's do remove object. It'll lead me through all of them. And now we only expect a circle. Period, and nothing else is masked, so they'll come through in the results. So now if we have a bad circle and a good circle, because it unmasked the settings, and actually we can see a little bit of the square, which I'll move out of the way, it's detecting a bad circle, a circle, and a square as well, so it fails the test. I'll put the square back in place. So these are conditions where it is detecting things that shouldn't be there, so they're considered defects. Alright, so we'll now remove the circle, and we're going to switch programs to square only. So this is on the far edge of the view, and its score is quite good. Now let's add in something we don't expect, like circle. Well, we already had circle. Let's use a bad circle. That one still passes. And the reason is because we have the masking in place again. So let's go back and remove the mask for this as well. It's back into Manage Calibrations. And we're working with the square in this case. We're on the square. And we're going to remove all the masks. Remove all the objects that we don't want, and now it will report back anything that it finds. It won't mask it, but only expect a single square in place. I'm going to do this to the other two too as we do our testing. So remove object, and then go through all of them. And on the plus, do the same. Remove all the objects. So the other thing I'd like to do is I'm going to turn on positional setting for the circle, so we can see the boxes and scores. And the way to do this is if I select an object and say Detector draw an image, I can go find so we're working in the shop PAQi 2 directory, and today's date. I'm going to go into the circle, put it in a view, so I can actually see the objects. So this looks like a good circle. So let's expect the circle there, and I'm going to let the detector, the colored block detector, find its position to set where it expects the position. So you'll notice this leads us back to the label and train program. And if I look over here on the right, it's showing both a bad circle and a circle. The reason it does that is because the threshold for doing auto detection is set rather low. So what we're going to want to do is just delete off the bad one, because what's happening is the detector's sensing both a bad circle and a circle on the circle, but it's scoring the bad as a low certainty score. So we get rid of the bad circle and just leave the good circle in place. And now this will set this area as where we expect to have our circle. And I'll show you how that works. Go ahead and save, close, and nothing else changes. So the calibration looks the same, but in the background it has stored the expected position of the circle. I'll save that, go back out. We'll continue with the square, and then we'll shift back to the circle so you can see the effects of the positioning. So now it fails because it detected defects. Detected a circle and a bad circle as well. We just saw that happen. Which is fine because we're showing that we found defects, unexpected things within the field of view. Even though the good square was there, we failed because there's also something that we expected not there based on the way we calibrated it. Go ahead and remove the circle and we should be back to pass again. We're going to move back to the circle this time, just to demonstrate what it does when you actually specify the position where you expect the circle. And this is not part of the test process, it's a part of the ability to tell an operator where there's a defect or something missing. So I switched over to the circle program, and I'm going to go ahead and snap a picture, and we get two boxes actually. So you can kind of see where the red and green are overlapping, and that is because it is detecting both the bad circle and the good circle in this area. Now if I were to remove the circle altogether, the program will say the circle is not found in this area, because that's how we calibrated it. We said expect a circle in this area. But note, if we don't turn on the expected positioning to be above 0%, overlap positioning, no matter where we put the circle, it's going to find it within the field of view and draw a box around it itself, and not where we calibrated it necessarily. So as I move this thing around, okay, so let's go and make some adjustments on the circle calibration. Back to the circle, and I had masked it earlier to prevent the duplicate boxes. But I'm going to actually remove it. I'm going to jack the score up on the good. So what this will do is say only allow this to pass if a circle is above 95% certainty. So we'd always rather fail false positive or false failure than a false positive. So let's see what happens when we increase that score. Okay, so it's also detecting the bad circle still, which we've already seen. So it's showing us that we found a good circle at above 99.5, and we found a bad circle at, I believe that's 93.48, and so it considers that a defect. So how do we solve this problem? One option would be to go back into the inspection setup and the circle calibration and increase the filter score. So let's set this to 94. So return anything above 94% certainty, pass anything above 95%. Now we could set these to the same amount, has the same effect. So now when I do a grab, it's passing. So what that did was just eliminate the defective one from the list that is analyzed. So I'm going to go ahead and stick a bad circle in there this time. So it fails because it found a bad circle at a high score, and it did not find the good circle. Notice that this box is over here to the right because that's how we calibrated it. Calibrated it that we expect the circle to be here. So let's do one more thing while we're at this. I'm going to put the circle back in place. So it is now seeing the bad circle again. So we really probably need to raise up the global filter. Try that one more time. In the end, the best way to solve this type of problem is just to train more. Train on more images of the circles, and I would include the other types of blocks around it like I did from the start. That concludes our tutorial on setting up a detector.